All right, in this lesson, we are going to graph, this graph of quadratic functions, basically. Now, our success criteria, okay, the objective is that students will represent graphically nonlinear relationships between two quantities and interpret features of the graph. They will understand the relationship between physical quantities via the graph. All right, so let's get to work on this. So the first thing that we gotta do is we gotta graph y equals x squared minus 2. Now notice that I don't have space for a t-chart or the t-table, but it doesn't matter because then we grab a piece of paper, right? And we're gonna start graphing it on the piece of paper. Let's see now. We'll go over here and you see what it is, right? So then what I'm gonna do is I'm gonna write here y equals x squared, okay, minus 2. So that is what I'm going to do. I need a table of values, so that's exactly what I'm gonna do. Now how do I create a table of values? Well, you create your own values. So I am going to just do my table right here. Okay, see that? Okay, you know what goes in here, you know what goes in here, and you know what goes in here, and definitely you know what goes in here. Okay, so now let's see. Here is my x. Here is the machine. The machine is called x squared minus 2. Here is the resulting y value, okay, and here's where you're gonna put your x comma y. So we're good with that, right? Okay. So now we're gonna give values. Now this is a quadratic function because the exponent, the highest exponent, is a 2, so it's x squared, quadratic function. So usually we give values like from we start at -3, -2, -1, 0, 1, 2, and 3. All right, and now we just plug the values into the machine. All right, so these are all the values that x is gonna take on, right? So here in parentheses, because I have negative values, I put -3 square, okay, instead of the x, now it's -3 because that's the value of the x, minus 2. Here, -2 square minus 2. Here, -1 square minus 2. 0 square minus 2. 1 square minus 2. 2 square minus 2. And here is what? Of course, 3 square minus 2. Okay. Now I need to know what these values will result in, right? I need to know what the result is. So I calculate. -3 square. We can use the calculator, of course, to find those values. So for example, this is the calculator, right? Let me see. Okay, better, brighter. Okay, good. So parentheses, -3 square, okay, minus 2. That is 7. Okay, so I get 7. And it makes sense. -3 square means -3 times -3, which is 9. 9 minus 2 is 7. Okay, then on the calculator again, I could put -2, okay, square minus 2, and I get 2. All right, and it makes sense. Look, -2 square is 4. 4 minus 2 is 2. -1 square is -1 times -1, which is 1 minus 2. 1 minus 2, you're taking away a larger quantity, so that's -1. 0 square is 0 minus 2, -2. 1 square is 1 minus 2 is -1. 2 square is 4 minus 2, 2. Okay, 3 square is 9 minus 2, 7. Wait, hold on a second. What do you notice about these values? Look, from this point on, the values repeat each other. Look, you see that? the y values return. So in other words, you go from the top of the y-axis, the bottom, the more bottom, even more bottom, and then you start going up, up, up. Okay. Now here you know what to write. Here you're gonna write the values. Okay. All right. Cool then. Let me see. Da, 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 da. All right. So here I put -3, 7. Here I put -2, 2. Here I put -1, -1. -0, -2. Okay. Why is this thing? Let me see. Okay, auto go with the mice is fine. Let's put it on. Should be intelligent, whatever. Okay. Okay. Let's continue with this. And this is 1, -1, 2, 2, and 3, 7. So these are the values that I'm going to be graphing. Okay, so let's start the graph. You show what the values are. If you need to pause and copy the values, then that's fine. We'll just rewind. So now on my grid right here, I'm going to start graphing the points. So let's see. This is the y-axis, this is the x-axis. This bottom here is -y, and this right here is -x, the sides. Okay, so this is the origin. So anything from here to here is negative, from here to here is negative. All right, let me start graphing the points. So -3, 7. To graph -3, 7, okay, -3 for the x, so -1, -2, -3, 7. 1, 2, 3, 4, 5, 6, 7. My point is right there. See that? Okay. And you could actually label it. Okay, -3, 7. All right, my next point. I think I should go a little darker with this pen. Let me see. Hopefully I have something darker. Oh, okay, okay. The next one is -2, 2. So this is -1, -2, 2. 2 is positive, so 1, 2. Then we have -1, -1. -1, -1. See that? Then we have 0, -2. 0, -1, -2. Okay, I'm doing this because I need you to actually learn how to plot the points. And it's not a bad idea to label them. Like for example, this one was -2, 2. This one was -1, -1. This one was 0, -2. Okay. Then we have the next value, which is 1, -1. 1, -1 right here. They start repeating. So everything that was up to this point is going to repeat going up. All these points are going to repeat going up because that's what quadratics do. All right. The next one is 2, 2. 2, 1, 2. See? Same distance. It's like a reflection of this curve is going to happen over here. So in other words, I don't even need to look at the table to know that the next value is going to be 3, 7. Look, 1, 2, 3. In other words, this one. 1, 2, 3, 1, 2, 3. And it's going to happen over here. All right. And now to trace your graph. It doesn't have to be perfect. It won't be perfect. But we could try. See that? I'm not tracing it with a straight ruler because basically the graph is not a straight, it's not made of straight intervals. It's a curve. So I'm trying my best right now. See that? And that's my curve right there. Okay, yours is gonna actually be better than mine's, because I am far away from the curve because I'm on the camera. All right, anyways, so we just finished graphing this. Let us go a little faster. Let's ask the questions. What does it mean for the graph of the parabola, okay, to touch the x-axis in terms of elevation? To touch the x-axis, it touches the x-axis right here and right here. What does it mean? It means that it has reached an elevation of 0. If it's elevation, the elevation is 0. So it means that the elevation is 0. And what does that really mean? It means that it hit the ground, right? But in terms of elevation, it means that the elevation is 0. Okay. Where's my dog? Oh my God, it's under the chair. I cannot move. Okay, cool. All right. Next question. What does it mean for the parabola to touch the x-axis in terms of time? To touch the x-axis in terms of time. Okay, I can tell you right now, it doesn't mean much. It doesn't affect time. But if, let's say, I was I was throwing something, right? Or I was going down the hill, right? And then down the swimming pool, whatever, and going this. Or I just threw an object going down. And with the same thing, the object is being propelled, so it actually can go back up. So if the object can actually go back up, then in terms of time, it only tells me the periods of time where the object was at 0. It tells me the time where the object hits the ground. So it doesn't affect time, but it tells me when or the time the graph or parabola hit the ground. Okay. Hopefully you understand that. If not, don't worry, I'll pause it and I'll explain to you. All right, pause it and you can just copy it down. So this is your parabola right here, your quadratic function. Okay, and we answered the questions. Let's move on to the next part. Okay. What do they want us to do here? It says graph the function of y equals x squared, y equals 2x squared, and y equals 3x squared on the same grid. How are the graphs similar and how are the graphs different? What did you notice? Okay, this graph does not exist, okay? You know what? Let me use color pencils and let me go into something else. Okay, here we go. This time I'm gonna have to use color pencils if I have color pencils. If not, Kobe, I don't wanna kill you. I'll be right back. Just gonna cover this. I need some color pencil. Okay. Got it. Okay. All right. I got color pencils, and now let's do this. I'm just doing the color pencil so you could actually see the graphs. And this time, okay, remember that we always have to create a table of values. Once you get your calculator, you won't have to create a table of values. All right. So, how do I do this? I have 3 graphs to do. All right, I got it. I'm gonna do it on the side. So X and Y. This time I am not going to do the whole T-chart, but you should always do it. Now, what did I do with the ruler? It's funny. Anyway, I don't even need the ruler, right? Yeah, no, I don't. So let's start. Okay, so I'm gonna zoom in on the table right here. So I'm gonna give values. Again, -3, -2, -1, 0, 1, 2, 3. Okay, so let's see. What am I doing right now? Well, I'm gonna do y equals x squared. So 3, -3 is x, so x squared. So -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. Oh look, after this one the values start repeating. That's what happens. 2 squared is 4 and 3 squared is 9. So let me start graphing these points. Okay, so you have them, right? So now all I have to do is come back over here and start graphing. So I gave the value of -3, right? -3 squared is 9. So I'm gonna go to -3. 1, 2, 3. -3 and then comma 9. So it's gonna be around here. I know this is 9 because the whole thing is 10. Okay. All right. The next one is gonna be -2 comma 4. -2 comma 1, 2, 3, 4. Okay. The next value is gonna be -1 comma 1. -1 comma 1. The next value is 0 comma 0. Okay. And then once you hit that, the next value is gonna be 1 comma 1. 1 comma 1. So it's right here. The next one is gonna be the reflection over here. And the next one is gonna be this reflection. So 1, 2, 3 from the y-axis. So 1, 2, 3 from the y-axis. And it only makes sense. So you see what the graph looks like, right? And now what I'm gonna do is I'm gonna connect the points because I am going to be doing other graphs. Okay? And now, okay, not perfect, but almost perfect. So that is my parabola. And now, to make sure that I understand, I'm going to label it. So this is y equals x squared. Okay. Now let's do the other one. What's the other one? I don't know. Which one are we doing? Let me do y equals 2x squared. Okay, I'm gonna do y equals 2x squared. So I have the little table right here. The table is going to be, oh, you know what? No, let me do it on this paper. Okay, y equals 2x squared. And I'm gonna create a table of values. So I have the x, okay. I have the machine, which is called 2x squared. I have the y value. And of course, I'm gonna have the order pairs, which I'm not gonna do. We're just gonna take them from the table, okay? Oh, okay. So let's see now. What values do I give? I usually give the same values, okay? -3, -2, -1, 0, 1, 2, 3. All right? Now, sometimes you might have to give different values for your parabola to be perfect, especially when you have different numbers. Okay, so -3. Let's do the machine. So 2 times -3 squared. Okay, -3 squared is 9 times 2, 18. I already know I'm not going to be able to graph that. But anyways. -2. So 2 times -2 squared. Okay. -2 squared is 4 times 2, 8. 2 times -1 squared. -1 squared is 1 times 2, 2. Remember, you're doing the exponent first, based on the order of operations. 2 times 0 squared. 0 squared is 0. 2 times 0 is 0. 1. 2 times 1 square. 1 square is 1 times 2, 2. Okay, so look, I just hit the turning point right here. Now the values start repeating. That means that I'm going to use 3 values above the turning point and 3 values below the turning point. 2, right? I don't even need to calculate this, because if this is 0, right, and above the 0 is a 2 and below the 0 is a 2, now this one is going to be an 8. Why? Because above the 2 we had an 8, so below the 2 is going to have it. And the next one is going to be 18. But let's see. 3 squared is 9 times 2, 18. Okay, so we got the points. I'm not going to do the order pairs. So let's see what's up. All right. That's it. Those are the points. And this is the graph. I'm going to make this a little smaller. Hopefully it won't. Now, you know what? You have the points right here. So take a look at them. Okay, now we're going to use those points to graph. Okay, so let's see now. The first point is negative 3, 18. I don't have 18 over here. It only goes up to 10, unfortunately. So I'm not going to go negative 3, 18 because I don't have it. And I'm not going to create a different scale, which I could, because I already have one graph in here. Okay, so then let's graph. Negative 3, 18, no can do. How about negative 2, 8? So negative 2, 8. Negative 2, 8. Can you see that color? No? Let me try a different one. This one better? Yes? Okay. Good. So let's see now. Alright. The next point. Negative 1, 2. Negative 1, 2. Right here. Next one. 0, 0. 0, 0 right here. Okay, cool. Next one. 1, 2. 1, 2. Oh, the values start repeating. You see that? Pam, pam, pam. And then that means that the next value is going to be around here. So, put the next value. Now let me graph this one. Okay, I hope you see it. Okay, the coefficient here was 1 and is the red graph. The coefficient here is a 2 and is the blue graph. And I'm gonna call it y equals 2x. Alright, so now I'm gonna graph y equals 3x squared, right? Sorry, I made a mistake before. I said 2x is 3x squared. Kobe, stop scratching the floor. Alright, so now I'm gonna graph y equals 3x squared. Let's see what's up with this. Alright, let me make a table of values. Okay. So negative 3, negative 2, negative 1, 0, 1, 2, 3. That's the dog. Kobe, stop. What in the world? Oh, sorry. Oh, okay. Something like that. That's my table of values. This time, my friends, it's time for technology. I'm going to show you how to use the calculator to do that. Got it? Okay, so if you have the calculator, good. If not, well, at least you're looking at it. So, I press y equals, and it's going to give me this menu. Then I am going to input my function, which is 3x squared. And now I'm going to graph. So that's what the graph should look like. But the graph itself is no good. I need a table of values. So we're going to press second, right here, second. And we're going to activate everything in blue. Notice that here it says table. So I'm going to click. And there you go. There you have the values. See that? So Negative 3 is 27. So I'm going to complete the table right here from the values that I see here. So negative 3 is 27. No good. Negative 2 is 12. Negative 1 is 3. 0 is 0. Okay. What else? 0 is 0. 1 is 3. Oh, they start repeating again. Okay. So they start repeating again. I know what 2 is. 2 is 12. And 3 is 27. Because that's how it goes. Alright, so now let's graph it. Okay. I'm gonna have to use one of those markers, but hopefully it works. So, or maybe not. Maybe I could use a different color. Let me see. Well, let's see if it works. All right. I cannot graph negative 3 comma 27 because 27 is all the way over here and I don't have that much luxury. Okay, but I could definitely graph negative 2 comma 12. Nope, I cannot. Gosh. Okay, maybe I could graph negative 1 comma 3. So negative 1 comma 3. Okay, where are the thingies? Where are the markers? Let me try this one. Okay, so negative 1 comma 3. Negative 1 comma 3. 1, 2, 3. Right here. Oh, it doesn't work. Oh my God. Okay. So here. Negative 1 comma 1, 2, 3. Right here. Oh, this one works. Okay. And then of course 0 comma 0. And then 1 comma 3. 1 comma 1, 2, 3. Okay. Now just as an example, if I was to graph negative 2 comma 12, that would be negative 2 comma something like this, the 12, right? Does it make sense? Yes. And if I was to graph 2 comma 12, that would be 2 comma 12. Why am I doing this? Just to show you something. So let me graph it now. I'm gonna do a dash. Wow, it's really bad. Okay. So that's basically what it is. Okay. Now, why did I do that? Well, because I need us to understand the difference. Okay. Look at what it says. It says, on the same grid, how are the graphs similar or how are the graphs different? What did you notice about the coefficient of x squared in regards to the width of the graph? Well, I can tell you right now, and I'm going to show it to you on the calculator. So the graphs were the following. X squared. That was the first one, right? That was the first graph. On the calculator I'm doing it. So I go and I graph. And that's what it looks like. Then I went, and of course, if you want the table of values, you could always get them from here. But anyways, then I went on and I pressed y equals again, and I actually graphed the other one. I know, Bex, if you could do that on the calculator, why are you doing it like, why you made us do by hand? I'm sorry, but you have to learn how to do it by hand. 2x squared. When I graph it, look at that. Boom. So the blue is the original x squared. The red is 2x squared. Let me graph the other one. 3x squared. And let us graph it. And that's the other one. So this one right here is the blue one, is x squared. This one is 2x squared. This one is 3x squared. The coefficient here, okay, the coefficient of the blue one, x squared, is 1. Okay? The coefficient here is 1. The coefficient here, the leading coefficient is 2. The leading coefficient is 3. What can you say about the graphs? How are they similar? Well, they're all quadratics. The graph of all of them is a parabola, or they all are parabolas. But how are they different? What did you notice about the coefficient of x squared in regards to the width of the graph? In other words, what does the coefficient have to do with the width of the graph? Well, that's for you to answer. Remember, the larger the coefficient, the higher the coefficient, then what happens to the parabola? It became narrower, skinnier, correct? Okay then. So that's about it for this one. So now you could place your answer right here on this space at the bottom. Let's move on to the next one. Okay. So we're supposed to graph this one right here. Okay? Let's see. Wow, it's a lot of time. Okay. We're supposed to graph those. So let's see. Y equals x squared, y equals 1/2 x squared, and y equals 1/4 of x squared. This time I'm going to help you by showing you the table of values on the calculator. Okay, so y equals, then we're gonna cancel these things, clear. So we have x squared. Okay, so create your table of values. You could go use the side of the calculator of the paper, right? I'm gonna show you table of values. So x squared, this is the graph of x squared. And now let's go to the table of values. Okay, we got the table of values here. So I usually start from -3, so I'm gonna do that. Okay. So -3, -2, -1, 0, 1, 2, 3. So -3, 9, because that's what it says here. -2, 4, -1, 1, 0, 0, 1, 1. Oh, again, they repeat again, so it's 4 and 9. And this is y equals x squared. Now let me do the table for the other one. And just remember, you have the table right here, so please copy it down. Okay, now before I graph, let me do the table for y equals 1/2 x squared. So I'm gonna go here, and I am going to press alpha y equals fraction, and I'm gonna put 1/2. See that? And now that's what the graph looks like. And I am going to take the table of values. Listen, the table of values, when you get the table of values, you don't have to graph every single point. No, just graph the nice points. So this is x, this is y. So I'm gonna graph, look, I'm gonna graph -4 because it's 8. Okay, I'm gonna graph -2 because it's 2. You see that? I'm not gonna graph, well, I could graph -1, 1/2, but I'd rather graph 0, 0. It's easy, right? And I'm not gonna graph 1, I'm gonna graph 2, 2. And I'm gonna graph 4, 8. See, those are nice points, and I have enough points to get the parabola, right? And now, last but not least, let us get set up the table for y equals 1/4 x squared. Okay, so I'm gonna go into my calculator. I'm gonna press y equals, I'm gonna clear that, and I'm gonna put alpha y equals fraction 1/4, move over, x squared. Okay, and that's what the graph looks like. Noticing some pattern? Sure. Okay, now let's take a look at the table of values. So let's see now. table of values, x, y, whoop, 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 whoop. Negative 8. Let's see what I can graph. When you're dealing with fractions, it's usually nice to just look at the calculator and graph the nice points. For example, look at this. I have negative 8, 16, but I know that I don't have a 16 on the y-axis. Oh, negative 6, 9. Okay, negative 6, 9. Beautiful. What else do I have? Negative 4, 4. Okay, negative 4, 4. Negative 2, 1. 0, 0. 2, 1. 4, 4. And I think I got 6, 9. Okay, so those are the values that I have. And now let's go and graph them. So for the parabola, this time I'm gonna do everything in pencil. All right, let's see, for the parabola. So I have x squared. So for x squared I have negative 3, 9, negative 1, 2, 3, 9. Okay, then I have negative 2, 4, negative 2, 1, 2, 3, 4. I got negative 1, 1, because you saw it, because you have the table. Negative 1, 1. I got 0, 0. I got 1, 1. Well, once the points turn, I already know what the next point is. I just go 1 unit here and I copy this point right here. Then I go here, it's 3 units from here, so 3 units from here is gonna be the point, 1, 2, 3. Okay? And now you have your parabola. I'm gonna have to turn it because I'm not good at. Okay, so I have my parabola. This is x squared. Okay, now let's draw the next graph. The other one is gonna be 1/2. Okay, 1/2. So I don't know if I should zoom out. Well, yeah, I'm gonna zoom out and I'm gonna just say what I'm graphing. So it's gonna be negative 4, negative 8. Negative 4, 1, 2, 3, 4, negative 8. I'm sorry, 8. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8. Then I have 2, 2. Sorry, negative 2, 2. Negative 2, 2. Then I have 0, 0. Then I have 2, 2. 2, 1, 2. Then I have 4, 8. So 4, 8. Or I could have just gone like that. All right, so my parabola looks like this. Okay, that's what my parabola looks like. And I'm gonna call it what? Y equals 1/2 x squared. X squared. Oh, okay. That's what I call it. Now let us graph the last one. Let's see. What can I use for this one? I'll just regular pencil. All right. So we're graphing now this table. Y equals 1/4 x squared. And we only chose the numbers that are nice. So let's see. Negative 6, 9. Negative 6. Negative 1, 2, 3, 4, 5, 6, 9. Right here. Negative 4, 4. Negative 1, 2, 3, 4, 4. 1, 2, 3, 4. Negative 2, 1. Negative 2, 1. 0, 0. 2, 1. 4, 4. 4, 1, 2, 3, 4. And 6, 9. 6, 1, 9. Okay, you see where this is going, right? So now let me trace this. Okay, and then my God, this is okay. So that's my graph. This graph right here is the graph of y equals 1/4 x squared. Okay then, now that you can see them, okay, and you know what, and let me just mark it with something different so you could see it better. Nope, doesn't work. Let me try blue. Okay, hopefully it's better. Anyway, so this is one graph, this is the other one, this is the other one. So we have graphed them. Now I'm gonna graph them on the calculator so you can have a better picture. But the idea is for us to actually know how to graph these things. So the first graph was x squared, right? And we got it right here. The second graph that you were asked to do was alpha y equals 1/2 move over x squared. Okay, and look at what happens. The second graph, oh look, the second parabola, it's different. Then the third graph that you were asked to do was alpha y equals 1/4 x squared. Okay, 1/4 of x squared, and that is the graph. I'm pretty sure you can make your conjecture right now. Okay, how are the graphs similar? Well, once again, they are all quadratic functions, and the graphs are parabolas. How are they different? Well, notice, what is the coefficient here? 1. What is the coefficient here? 1/2. What is the coefficient here? 1/4. Which one is greater? 1, 1/2, or 1/4? 1, right? Then which one is greater? 1/2 or 1/4? 1/2, right? And then 1/4. So if the number is less than 1, okay, or greater than if the coefficient is between 0 and 1, okay, the closer the coefficient is to 0, then look at this, 1, 1/2, 1/4. So if the coefficient was like 0.1, then it will be something like this. The parabola will get wider. Got it? Cool then. Okay, so let us move on with the next one. Okay. So writing piece. What conclusion can you draw with respect to the width of the graph and the coefficient of x? Sure. If the coefficient is greater than let's say greater than 1, the parabola becomes narrower. Okay? If the coefficient is less than 1 but not 0, then the parabola then the parabola becomes wider. Okay? Okay? We're good with that? All right then. Let's see now. Without graphing the function, what can be said about the graphs of y equals 2x squared and y equal 1/2 x squared? That, my friends, is up to you. I'm not going to answer that question. Okay, that's it. This is the last graph. And guess what? You are not going to get any help from me. So I suggest you start working on, if you want to create a table of values, good. If you have a calculator, you can just get the values from there, do it, okay? All right, good. So start working. Continue. All right, I hope you had enough time. So let's see what's up. Let's graph y equals 2x first. All right. So basically for every value of y, x is gonna get multiplied. For every value of x, y gets multiplied by 2. So if x is -3, -3 times 2 is -6, right? But anyways, that's why I have the calculator right here. So 2x. Now let me look at the table of values. So -3, -6. -3, 1, 2, 3, -6, 1, 2, 3, 4, 5, 6. Okay, right here. Then the next value would be -2, -4. -2, -4. 1, 2, 3, 4 right here. And anyways, look. the rate of change here is whatever multiplies the x. This is 2 over 1. This is the slope, okay, the rate of change. So for every 2 that I go up, I'm gonna go 1 to the right. And it only makes sense. Look, I already started. Look, 2 up, 1 to the right. So the next one is gonna be 2 up, 1 to the right, 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 2 up, 1 to the right. And I get my straight line. And now all I have to do is trace it. Okay, now remember, make a table of values. Me, because I already have the graph right here, or at least use the calculator to show the values. And you make a little table of values from the values that you get on the calculator. All right, the next one was going to be a half x squared. Okay, so a half, okay, x squared. I have x squared. There you go. So table of values for that. So we got negative 4 comma negative 8. So negative 4, 1, 2, 3, 4, 1, 2, 3, 8. Okay, right here. Okay, then we had, I cannot graph this, so I'm gonna have negative 2 comma 2. Okay, negative 2 comma 2, so negative 2 comma 2 right here. Then 0 comma 0, then 2 comma 2, 1, 2 comma 2, 4 comma 8, 1, 2, 3, 4 comma 8 right here. Actually, wow, that was crazy. I'm gonna have to make this line a little longer. Oh, okay. So that's it. Now you have the graph right here. And of course, right here. See that? So yes, do the graphs intersect? Yes, they do. What does it mean for the graphs to have the intersection points? Why do they intersect? Well, to have the same intersection points, that means that they both have the points of intersection. At that point, the two graphs have the same order pair in common. Like for example here, they have 0, 0. So I'm gonna write that they have the same order pair in common. Yes. What does it mean? It means that at the point of intersection, okay, the graphs share the same values for x and y. At that point, the graphs, you could say, are like the same. At that point, only at that point, the graphs are the same. Okay, for x and y. Like in the, you see, same values for x and y, which is the case. Which is the case at points 0, 0 and what is this right here? 4, 8. Okay. Now, let us try that theory on the calculator. I want to see if it's true. So I'm going to graph the two lines and I'm going to look at the tables to see if what I'm saying is true. Okay? So this is the graph. Okay, so let's just look at the calculator. If you need to go back, I'll go back. So this is the graph of 1/2 x squared. and this is the graph of 2x. Let's graph them. So we're gonna see that. Now let's take a, this doesn't tell me much. It tells me that they're gonna intersect. I can barely see where, but let's take a look at the tables. So now look at 0, 0, 0, 0, and 0, 0 for both. You see, for this, for the blue graph and for the red graph. So it works. Also, look at 4, 4,8 for the blue graph and 4,8 for the red graph. Okay, the blue, which is the quadratic, and the red, which is the linear. So that's what it means. Those are intersection points. Those are, in the future, we're not gonna call those just intersections. We're gonna call them solutions. My God, this session has been so boring. I haven't done anything. I caught you. Of course I caught you. All right, so that's it for this lesson. Bye-bye.